And we have, very, important concept of flux. Okay? From the surface integral of vector field, let's say we have a surface integral. This is density. Rho is density. And v is velocity. Let's say this is fluid dynamics. Okay? You're mathematically describing fluid of water, fluid of gas, fluid of air. Okay? In that case, surface integral is really important. And we have flux. If it is density times velocity, the field is, okay? Then we call the surface integral flux. Okay? So meaning is mass of fluid crossing the surface as per unit time. Right? So the integration of surface integral, right, as f and dA is flux. If f is this. Okay? That's what it means. Let's see example 1. All right? So we have this surface. Okay, this is a surface. Okay? And we have vector field like this. F is, this is the velocity vector. Vector field is 3c square 6xz. Okay? So that's the vector field, around this space. Okay, I'm not going to draw it. Okay, in that case, we have to get the flux. When rho is 1 gram per cubic centimeter. Okay? And then, this surface, description of the surface is this. So x is u, c is v, and y is x square, which is u square. All right? So looking at this surface, we have this parameterization. You could have different parameterization, but this one is kind of natural selection. All right? And so u is from 0 to 2, and v is from 0 to 3. Okay? That's the... all right. So n vector is r cross u, ru cross rv. That's... r is this one, that one, right? So that's 1, 2, u, comma 0, cross 0, comma 0, 1, which is 2u, comma minus 1, comma 0. All right? And f of s is you plug it in, x of, uv. So f dot d n dA is from 0 to 3, from 0 to 2, and that's 6 uv square minus 6, okay, du dv. Okay, and if you calculate it, let me skip the calculation. That's 72. That's cubic meter, by second. All right, example 2. So it's a plane surface. Okay, this one is plane. Actually, right? It is inclined onto XYZ coordinates, and the part of this is shown. Okay, from 1, 1, 1. So only part of that is considered to be surface. Okay, this is surface. This is a plane that's inclined, right? And that's where we get surface, right? So the vector field is x square 0, 3y square. How do you parameterize it? Okay, so z is 1 minus x minus y is 1 minus u minus v. All right, so r of uv is what? uv times 1 minus u minus v. All right? And here u is 1 minus v. V is 0 to 1. Okay? And all you need to do is to get n vector ru cross rv. That's 1, 1, 1 in this case. Okay? And so f dot n is u square plus 3v square. All right? So the integration, the line integral of vector field is 0 to 1, 0 to 1 minus v u square plus 3v square du dv. Okay, the calculating is 1 over 3. So we just talked about surfaces, right? But in the case of the curve C, we used to have positiveness, right? So the counterclockwise is always positiveness. Okay, so counterclockwise meaning actually. So right hand screw rule, okay? So this is counterclocking, right? And, upward that goes to the surfaces, right? So let's look at this surface. So this is a surface, and we have boundary, curve, C, okay? In that case, so the C, moves, counterclockwise, and the normal vector to the surface is upward. That is positive. Positive surface. Okay? And on the other hand, if you have that C has clockwise rotation, then your hand should be flipped down, right? Then it's negative. And that's negative surface. Okay? And you could have piecewise surface too. So this one is connected, and each one has their own rotation of C boundary, right? That has to be positive. Okay, since it's a counterclockwise. But if the other one is in negative, that means it cancels each other. It may be, right, during the calculation. That's the orientation of surfaces. But you have to remember that not all the surfaces has positive or negative. You have Möbius. Remember that the Möbius, strip. You start from 1, and then you go back to that point. Okay, that's a Möbius strip, and this one has no sign. Okay, no positiveness, no negativeness, right? Because you cannot separate the this continuity, right? Okay, I'm gonna just briefly review that orientation, and you can understand that. And we have some examples. I guess that's you can understand that, so you can try it on. And some of them I already covered.